Yesterday we talked about summing up a sequence, also known as an arithmetic series, and we had a formula, and the formula had several parts: a sub 1 plus a sub 2, or a sub n, over 2, all times n. And that was kind of an adding machine that added up all of the terms together and gave us a sum. Well, today we're going to be doing the same thing with geometric series. The formula is more complicated, but it's much easier to use because in the arithmetic formula, we needed to know the first term and the last term, and sometimes finding the last term was a lot of work. But the geometric series formula does not need a sub n. All you need is the first term, the common ratio, and the number of terms, and then you can calculate it. So the formula is this: S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. We also need to put that in parentheses. No. So all you need is the first term, the common ratio, and the number of terms. You do not need to know a sub n, the last term. But sometimes they give you the last term and you need to find n anyways. So look at number 1. So for number 1, do I know the first term? Yes. Do I know the common ratio? Well, if I look here, times 6, times 6, times 6. So my first term is 2 times, oops, I want to write it that way, times 1 minus 6. How many terms are there? 4 terms over 1 minus 6. So in my calculator, 2 times 1 minus 6 raised to the 4th divided by, well, you could do 1 minus 6, but what is 1 minus 6? Negative 5. And I get 518, which is exactly what the same thing I would get if I added those numbers together. So that first set is super easy. Okay. When we move on to the next set, let's remember what the formula, the explicit formula is. Yes? Your brain? Run like a speedy gazelle, making that little girl noise you made when you came in. Yep. I don't know, screaming like little girls. Okay, so remember the formula is this: a sub n equals a sub 1 times r to the n minus 1. That's the explicit formula for a geometric sequence. So you state the first term, you multiply it by the common ratio, and you raise it to the n minus 1. So in these sigma problems, the summation problems, it will give you the explicit formula. Okay, so look at number 5. When we did this with arithmetic sequences, we needed to find the first term and the last term. But here I don't need to find the last term, I just need the first term. So I plug in 1, 4 to the k minus 1, which is 4 to the 1 minus 1, which is 4 to the 0, equals 4 to the 0 is 1. So 1 times 1 minus, what is the common ratio? So remember my formula is a sub n equals a sub 1 times r to the n minus 1. So this number is the common ratio. What is that number in this problem? 4 raised to the, how many numbers are in the list? We have a sub 1, a sub 2, a sub 3, a sub 4, 5, 6, and 7. Try that again. 1, 2, 3, 4, 5, 6, 7. 7. Yeah. 1, 2, 3, 4, 5, 6, 7. So, I think you're confused with the n minus 1, right? You're used to subtracting 1. So, n tells me how many numbers are in the list. It's like going back to the theater problem. How many rows are in the theater? Well, there's a row 1, there's a row 2, and 3, and 4, and 5, and 6, and 7. If you start at row 1 and you end at row 7, how many rows are there? There's row 1, there's row 2, there's row 3, row 4, row 5, row 6, row 7. That's 7 rows. Now, the distance from 1 to 7 is 6. There are 6 numbers between them, but 1 is one of the numbers, so 7. Well, we're using this formula, but I'm going to show you in a second that this one's going to help. Okay? Over 1 minus r. Okay, now, we can be smarter than this. I calculated 1 by plugging in 1. But this formula is already written in that form. This formula gave me a sub 1. What number is in front of the 4? 1. So it's really 1 times 4 to the k minus 1. So in the arithmetic formula, we had to plug in 1 to calculate a sub 1. We had to plug in n to calculate a sub n. And in this case, they're both given in the equation. So if I had 6 times negative 2 to the n minus 1, everything I need for the formula is, well, and then I had summation from k equals 1 to 8. Everything I need is given right there. I don't need to calculate anything to create the equation. This is my first term. This is my common ratio. And this is my n value. So today is way easier than what we did the other day. So what you're going to do is, well, I don't need this, right? So 1 minus 4 raised to the 7th. And I'm going to divide that by 1 minus 4, which is negative 3. So 5461. Find it? Oh, good. You scream like a little girl? Just for the record, for those of you at home, Dylan Fancy screams like a little girl. Okay. There is one case where you have to be careful, and you'll make a mistake that creates just a small little problem that will confuse you. And an example is number 9. So for number 9, what is a sub 1? This is a sub 1. So to fill out the S sub n formula, we have 2 times, what is 1 minus r to the n? What is r? Negative 2. So what would be 1 plus r? 1 plus, well, it's 1 minus negative 2, which is actually, well, you can't, it's got an n on it, so you can't combine the 1 and the 2. But this negative changes it to positive. So watch this, because we're going to make a mistake here in a second that's going to mess up your problem. So 1 plus 2 to the 8th over 1, it's 1 minus negative 2, which turns into 1 plus 2. Okay, watch this. So 2 times 1 plus 2 raised to the 8th, and then I'm going to divide that by 3. And I get, wait a minute, that doesn't make any sense. Okay, somehow I added up all these numbers and I got a decimal. And none of the numbers are decimals. So the pattern is times -2. So 2 is the first number, and then times -2 would be -4, and then -8, or +8, and then -16, and then +32, and I keep going out, and then I add all those numbers together. Should I get a decimal? No. They're all integers, and if you add integers, you should get integers. The problem is right here. The formula states 1 minus r to the n, right? So it's 1 minus -2 to the n. But this n is on the -2, right? So, can I combine this negative and that negative? No. Because order of operations says, before I can move outside the parentheses, I need to raise it to the n power. So what happened was, my number was slightly bigger than it was supposed to be. So it should be 2 times 1 minus, here's the trick, you have to put parenthesis -2 raised to the n. What was it, 8? Like that. If you don't put that parenthesis, the calculator is going to change those two negatives to a positive, which is not the case. So whenever you have a negative number raised to an exponent, you need to put parentheses. Now, do I have the same problem in the denominator? Do I need to do 1 minus -2 in the denominator? No, why not? It doesn't have a raised to the n, so I can go ahead and divide it by 3, and you'll notice that the answers are really close. I mean, number-wise. 171 and 170. But that is the sum. So if your r is negative, when you plug it in the formula, this sign should never be a plus. It's either minus something to the n or minus negative something to the n. The bottom can be either a plus or a minus depending on your r value. Okay? So that'll take you all the way down to number 19. Do we have all the information we need to calculate 19? That's my drink of liquid bird. Do I have a sub 1? Yes. Do I have r? Yes. Do I have n? No. What does n represent? The number of terms. The number of the term. So this starts with 4. And what happens to 4 to make it to the next term? Times by -2. So 4, then -8, then 16, then -32, and eventually I hit 1024. That would be a sub 1, a sub 2, a sub 3, a sub 4, and this is a sub n. What I need is that number. If I know that number, then I can fill out the sum formula. How am I going to find it? Here's a really bad way. Times -2, enter. Times -2, enter. Times -2, enter. When you get there, you count them all up. The what? This one's not going to turn into a quadratic. So those quadratics we had yesterday, they don't happen today. Well, You're close. You're close. So, what is the a sub n formula? We just went over it a minute ago. A sub n equals a sub 1 times r raised to the n minus 1. So if I want to know n, what parts of this equation do I already know? I know this one, I know this one, and I know this one. I can use those to find n. The trouble is, when the variable is in the exponent, I can't solve it using algebra, at least not yet. So how did we do it? We did this a lot. Well, we could divide by a sub 1, and then we'd have to do the n minus 1 root, which doesn't exist. So the formula is, boy. So I want to do 1024 equals 4 times negative 2 to the n minus 1. I could divide by 4, but after that I'm stuck. So I could guess. I could plug in 1 and try it, see if it works. I could plug in 2 and try it, see if it works. But there's a faster way to guess. Put it in your y equals. So pull out your calculators. So 4 times, and in this case, the negative 2 must be in parentheses. Negative 2 raised to the x minus 1. Now when I go into my table, what am I looking for? I'm looking for 1024, which is n equals 9. So the 9th term in this sequence is 1024. Does that answer the problem? What is the question asking for? Which equation? It wants the sum. Do I know the sum? Not yet. So, I know a sub 1 is 4 times 1 minus negative 2 raised to the 9th over 1 minus 2. Does that make sense? So in my calculator, 4 times 1 minus 2, minus parenthesis negative 2 to the 9th. Oh, shoot. No, that's right. There we go. Oh, boy. That's not what I wanted. All right. And then I'm going to divide that by 1 plus 2 is 3. Oh, my goodness. And that's the sum. Now, that seems a little strange. Why is the sum smaller than my last term? If I had a whole bunch of numbers and I added them all up, why is the sum smaller than the last term? It's going up and down. It jumps from positives to negatives. Every other number is negative. So it's growing, but it's not growing very fast because it keeps bouncing between positive and negative numbers. So that will happen whenever your r is a negative number. Okay. So for number 21, determine the number of terms n in each sequence. I know the first term is negative 2. I know r is 5, and I know that the sum is negative 62, and I need to find n. So let's fill everything into the equation. Negative 62 equals negative 2 times 1 minus 5 to the n over 1 minus 5. I have the same problem here. I have an n in the exponent. If there's an n in the exponent, you don't know how to solve it, so plug it into your y equals and see where negative 62 is. Okay, now everybody do this because it's a little bit tricky to type this in. So negative 2, the top needs parentheses, 1 minus 5 raised to the x, close the parenthesis, and then what is the denominator? It's just negative 4. So we'll divide that by negative 4. And then we do second graph, and we find negative 62, which is n equals 3. If you look at number 25, I have everything I need except what do I not have on number 25? I don't have r. Can I find r? What is r? You fixed it? So r is negative 4. So each time we're multiplying by negative 4. When you type this in your calculator, so it'll be negative 4 times parenthesis 1 minus negative 4 to the n over 1 minus negative 4 is just 5. You need to type it in like this with 2 sets of parentheses or it won't work. Whenever that r value is negative, you'll need 2 sets of parentheses. All right. Good luck.